Hello students, in my last lecture I had discussed activities related to refraction of light. I had explained activity 10.9 and 10.10 of NCERT science book. But with the demand of different students, I am repeating activity 10.10 once again. Many students have taught me to repeat it again. It is very important for us because it is the part of theory and it is very important practical of our class 10 physics also. So this activity states as refraction of light, refraction of light through a rectangular glass slab. Rectangular glass slab. It is very important that this topic is also given in class 8 physics. So, if your younger brother or sister is at present in class 8, then you can give them a reference to learn it. It is very important from them also. So see, what is refraction of light through rectangular glass slab? How we shall perform this activity inside our science lab? I am trying to sketch it on larger scale. So suppose, see here, we take A4 size white page and put a glass slab. We fix this white page on drawing board with the help of board pins, and at the center of this we put glass slab and draw the boundary of glass slab with the help of a pencil. We draw the boundary of the glass slab with the help of a pencil. After drawing boundary, we remove glass slab from its original condition. Suppose this is the boundary A, B, C, D. This is the boundary of glass slab. So here this is air and this is our glass slab. Glass slab. Now at this line AB, we draw an oblique line with the help of a scale. Suppose this is a line at point O. What is the practical really? Now on this line, we install two paper pins. Suppose one pin is installed here and another pin is here. We install two pins, suppose at point E and F. Really, what is the practical? Now, we have to install two more pins with the help of images of these two through surface CD. So, we sit down at the height of this glass slab and try to install two more pins in such a way all four pins appear in a straight line. Now see, we have read a lot of properties. In my first class, I had discussed you the first property of light, which we have read in class 6, and this property is rectilinear propagation of light. So due to rectilinear propagation of light, light always travels on a straight path. So if the light travels on a straight path, then the images of these two pins should be visualized at any point on this line. But what we see? We see that due to refraction of light, images of these two pins E and F appears in such a way that we install two more pins on points G and H. Suppose this is point G and this is point H. In such a way, all four pins appear in a straight line. So, this is refraction of light. Now, as we know that with the help of 2 points, one and only one line can be drawn. So we meet these 2 points with the help of a scale. See, we join these 2 points with the help of a scale. Suppose here it is point O dash. Now once again we join point O and O dash with the help of a scale. We draw a normal at point O and O dash with the help of our protractor or compass. So suppose this is normal at point O. We draw a normal at point O. Suppose this normal is N dash, and at this point O dash, this normal is M dash. Now clearly we can see that suppose this is incident ray, this is our refracted ray, and once again at the surface of CD here double refraction of light takes place. First ray of light incident at AB surface of the glass slab, and it is refracted in the direction OO dash. Again at surface CD it go in air and double refraction takes place here. So this ray GH is also called refracted ray or emergent ray. Now as we know that the angle between incident ray and normal is called angle of incidence. So suppose this angle I1 is angle of incidence. Here the angle between normal and refracted ray is called angle of refraction. So suppose this angle R1 is angle of refraction. Once again at this point O, the angle between incident ray, this is incident ray and this is normal, it is angle of incidence. Suppose it is represented by I2. And finally the angle between normal and refracted ray or emergent ray is called angle of this refraction, or this is angle of emergence. Finally, if we measure these two angles, then what we find? We find here angle I1 is equal to angle R2, and we can say that angle of incidence is equal to angle of emergence. The distance between these 2 point lines, this is the path of original ray of light. This is the path of original ray of light, and this is the path of refracted ray of light, and the distance between these two is called lateral displacement. So the distance between original ray and the refracted ray, this is called our lateral displacement. This is called lateral displacement. Lateral displacement. So really try to learn to draw a ray diagram through a rectangular glass slab, and once again I am giving you the home assignment to trace it clearly 3 to 4 times. So once again your homework is that, because our motto is to learn it really, not only to complete our syllabus. So draw ray diagram for refraction of light through a rectangular glass slab. Thank you very much.